Hello, everyone, and welcome to the fifth and final episode of this networking series. If you have not taken a peek at those first few episodes yet, there is a playlist link in the description. I do recommend going through and watching those first, as they do provide good context to what we're going to be talking about today. We're going to be finishing it off here with ports and protocols, which is layer 4 on the OSI and the 5-layer model. On the TCP/IP model, it is layer 3 again. That was discussed in the very first episode, that overview of those networking models. But let's dive into ports and protocols. We're going to start this off with protocols. We're going to discuss ports just a little bit later here. Protocols define the type of communication on the ports. Well, there's two primary protocols for communication on this layer. That is TCP and UDP. TCP stands for Transport Control Protocol, whereas UDP stands for User Datagram Protocol. We're going to compare these a little bit. TCP is typically used for scenarios where encryption or data integrity is key or most important. This is going to be web traffic, file transfers, stuff like emailing, stuff where deliverability is guaranteed. UDP is typically used where data speed is most critical. This may be online gaming, video streaming, voice over IP phones, stuff like that. TCP requires an initial handshake connection. There has to be some general communications data processed first. Both endpoints have to kind of agree on how we're gonna talk. But what this does is it ensures all data makes it across in the correct order. So all data makes it across and in the correct order on TCP. This is a slower method, but data integrity is guaranteed. UDP allows for real-time data transfer. It does function better on slower networks. Data could be lost in transmission, and delivery is not guaranteed over UDP, however. Let's chat through ports a little bit. Well, what is a network port? Well, it allows for multiple channels. It allows multiple channels for communication between hosts. Simply put, they do range from 1 to 65,535. Some services do have some standard or default ports, but let's look at a practical example here. IP address A sends a request originating on port 55123 to IP address B on port 443. Kind of looks something like this. Requested data, not date. Apologize for the typo there. Both IP A and IP B can still have other outbound or inbound requests on different ports simultaneously without conflict. So, multiple ports allows for multiple simultaneous connections, which is super good when we are trying to utilize, even multiple browser tabs, multiple programs to say the least. Usually a single browser tab is going to take up a couple different ports on your computer there, and this does allow for simultaneous use of a connection or of an IP address interface. I'm going to talk through a couple of the default ports that exist. You might see these ones a little bit every day if you work in networking or computers at all. SSH utilizes port 22 on TCP. Again, anything TCP is where there is encryption as an option and data integrity is critical. SSH is super important that, there's encryption. The S in SSH, the first S stands for secure. So it's secure shell. HTTP or web browser traffic utilizes TCP. Again, HTTPS utilizes port 443 over TCP. It's where encryption is guaranteed over internet. NTP is network time protocol. It's getting timestamps from public or available time servers, having a centralized time server for a system. And that utilizes UDP because all it needs is just the data back. You just reach out, say, hey, what's the time? It says, hey, here's the time. And that's as far as the data goes. It does not need to be over TCP, so it is over UDP. SMBv2, which is a file sharing protocol, utilizes 445 over TCP. DNS utilizes 53 again over UDP. RDP, it is a video streaming service, but it does require some encryption. So it can actually be used as a combination of both TCP and UDP. Oftentimes it starts over TCP to establish encryption, establish a communications channel, and then it switches over to UDP for the actual data or video stream. This allows for higher performance or throughput, a little bit better performance, while still utilizing the TCP encryption. SMTPS, or Simple Mail Transport Protocol, it's an email service. The secure ports for that are 587 over TLS or 465 over just SSL. IMAP secure utilizes 993 over TCP. There's a lot of ports that are pretty standard or typical. Sometimes and oftentimes these can be changed for security, for obscuring the actual service that's behind it. But these are the typical ones that you will see day to day on their default ports. We're going to discuss a little bit of PAT, which stands for Port Address Translation. It's quite similar to NAT, except that Port Address Translation rewrites the ports on traffic as opposed to the actual network address. Typically, this is done by the NAT device functioning at that layer for that transport layer. This may be used for security or for maintaining standard ports on a port forward. Essentially a request might come into port 443 on your public address, and you're going to rewrite it to whatever, 8443. You're going to rewrite it something headed down when it hits your actual web server behind a NAT device or behind your PAT device. Let's take a peek at a UDP segment. UDP segments and TCP segments. Segments are the data similar to frames and packets, but it's what the data is called at this layer is a data segment. Again, UDP and TCP are quite different in how they perform, so we're going to look at those different segments individually. For UDP, we're going to have the source port, we're going to have the destination port, we're going to have the segment length, we're going to have a checksum. This is optional in UDP, however, and we are going to have the actual data. Take a peek at each item a little bit more in depth. Source port, obvious, the port the request originated from. Destination port is the port the request is headed towards. Segment length is the total length of the segment. Checksum is optional in UDP again, but it's a checksum for segment data, kind of make sure everything is intact. Data is the session layer data. Here we can see that, yeah, the TCP segment has a lot more items in it. Let's take a peek here. Again, we got to have the source port. We got to have the destination port. We have something called a sequence number. We have an acknowledgement number. We have header length. We have reserved section. We have code. We have window. We have checksum. We have urgent flags. We have options flags. We have pad. And we ended off with data. Again, we'll take a peek at each one of these individually a little bit more in depth. Source port, destination port, obviously port it originated from, the port it's headed towards. Sequence number is used to reassemble any segments received out of order. Again, TCP is all about ensuring data exists in its entirety and in the correct order. Sequence numbers are important for that. Acknowledgement number contains the sequence number the recipient should expect to receive next as that next piece of data. Header length, again, defines the length of the segment header. Reserved is not currently being used in this segment. It's potentially reserved for future use. With IP address space, it's reserved for future use, never happens. We'll see how that goes. But there is an empty space currently in the TCP segment that's reserved. Code indicates the type of data request. This is over TCP. There are some general requests that are for establishing the communication there. That's what that code section is used for. Window specifies the number of bytes in the next segment. Checksum obviously contains just to check some data for the segment to check for integrity. Unlike UDP, it is not optional in the TCP segment because, again, data integrity is most important in this protocol. Urgent is used to expedite the delivery of this segment to the data receiving the process. This might be utilized if there has to be a retransmit request where where you're transmitting the data did not receive the data the first time. So, hey, we need to get it through. We need to get it fast to make sure that all the data is there. Urgent flag comes into play. Options is typically used for additional information, security information, or timestamps. Again, when we're talking encryption, timestamps is super important. And when we embed those into the TCP segment, we're ensuring that, packets didn't age during transit, they're not invalid now, stuff like that. The pad ensures the segment header is a multiple of 32 bits. Again, we saw this with the layer 3 packet. Data, again, the actual segment data that functions at the next layer, the session layer. That is going to bring us to the end of this overview of ports and protocols. And with that, we have checked off our final item meant to discuss. If you have any questions, again, please feel free to leave them in the comments. I do request that if there's questions pertaining to a specific layer or specific scenario or thing mentioned in any of these videos, I do request that you leave them in the comments for that specific video. That way there's a little bit more context to the question when going back through them. There is a Discord server in the description of all of these, and there is a playlist containing all of these episodes together in the description. Feel free to leave your questions anywhere, and we'll see if we can get you an answer to any of those. Thank you for watching through this series, and I hope you enjoyed it. I hope it was informative. Hope you learned something, and we'll see you with whatever comes next.